Hello everyone, I am Aparna Raut here presenting my topic Regional Trends and Physical Controls of Streamflow Drought Characteristics in Tropical Catchments. All these are my co-authors. I am from IIT Kharagpur. This study is being funded by DST SERV and also DAD have been supported me while my master thesis, and I am going to present this on EGU General Assembly 2022. Streamflow drought, regional and global impacts. Are we experiencing more hot and dry extremes? Ask this question to yourself. So, first we'll make some knowledge on our global impacts. Here is a report which says every fifth child faces water scarcity globally. So, it is the current situations. So, what is going to happen in next few years? More than 155 million children in South Asia live in areas with high or even extremely high water vulnerability. So these are the things which let us generalize our focus towards the water scarcity and the drought episodes. Then another report says drought forever. Severe drought strikes India every 8 to 9 years, and it is a major reason for perpetuating poverty. So how drought is impacting? It impacting the poverty also. Not only it impacts the poverty, also it shows water crisis due to low rainfall hampers energy power generation in India. So this energy and power generation is very essential being and making the water crisis or the drought conditions will impact it severely. And another report says India's water crisis, the seen and unseen. As many of 256 out of 700 districts report critically or overexploited groundwater levels as of 2017. So this is 2022, and the report should, if the report will analyze, that will be more. So the numbers will be more. Not only that, this is a water stress level map of India, and this is our regional study area. So here what it says, the water stress are more in this peninsular regions. Now diverting your focus to how and why, what is the rationale and what is the research gaps. Ever wonder the relationship between unset timing and deficit volume? So this study focuses on the relationship that exists between the timing of the drought onset and the deficit volume. So these are how these drivers are interrelated. There are several drivers like severity, which is known as deficit volume, the frequency of the drought, catchment characteristics, the duration of drought, and the time of onset. How these drivers are interrelated? Have you there are till now there has been no studies which explains this. So we will going to focus on these things and provide our results. No studies have been thought investigated concurrent trend in drought onset and severity. Similar studies were found for floods and other extremes. So, where Chain and others and Vasco and others in the year of 2020 have described for different other different events like floods, but there has been no study investigated for the trends in the drought onset and severity. And there is drought reach or poor period and its drivers physical controls were not investigated. So the onset timing is of importance in our study. And what we are going to what is the basic motto of this study? We are understanding the stream flow drought, we are capturing the seasonality, and also then describe the regional trends, how the regional trend is there, how the what are the physical controls, and understanding their synthesis and changes in the hydrological cycle. And does it impact our freshwater supply? If it implies, how can we how we need to tackle in the future, and what should be the steps we should take further. Now coming to river basin in peninsular India, which is our focus and study area, which have 82 gauge stations of observed data from the period of 1965 to 2018. All these data sets are obtained from the WRIS site of India, and these are all peninsular catchments, so they depends on solely on rainfall. So these are all rainfall fed catchments. They are like 16 river basins. Some of these river basins are mentioned here. Regionalization of drought, concurrence, onset, and deficit volume. Now we'll understand how what we have done in our study. So we observed we've obtained the observed daily stream flow record, and then we apply the variable threshold method, that is Q80, for identification of hydrological drought. After identifying the hydrological drought, we obtain the like onset timing and the drought deficit volume. So for each event we got an onset time, and also we got an drought deficit volume. So yearly changes in deficit volume, we observe the trend for that. We observe the trend in the onset, how the onset is shifting by time. And also then we observe the synchronicity in the streamflow dot. We observe the temporal coherency using linear and circular dependency, and also we observe spatial coherency using density based clustering. Then we went for the regionalization of drought vulnerable zones, where we found like three zones using the density based scan method. And also then we attributed the rainfall and the soil moisture, soil attributes, and the topographic attributes. The rainfall and the soil moisture, while these are the dynamic features, soil attribution and topographic attributes being the static feature. So what will this in broad scale will do? This will help us for drought vulnerability mapping and the regional resilient planning of the drought. And it will help for ecosystem, livelihood, public health, agriculture, and multi-sector impact. Now, understanding annual and seasonal trends in drought onset. So here we consider the drought or that have been occurred, that have been occurred or observed in the observation period, and we consider it is all season, and then we divide it into different seasons like summer, monsoon, and winter. The summer is from March, April, May, and monsoon includes the June, July, August, and September, and the winter obtains the remaining one, the October, November, December, January, and February months. So here what we saw, this 60% air station so delayed onset. So in, why it is why the onset is being delayed and how much it is being delayed. So the onset is being delayed for 0 to 5 days, like more than 1 to 5 days. The delay has been happening in the observational trend. And it is the all season trend is more influenced by monsoon, because the monsoon, in monsoon the number of droughts happening is more. Why this is happening, the numbers of droughts happening in monsoon is more? Because in case of this Indian core monsoon zone, what Roxy and others have been found in the in a paper they have mentioned in the year of 2017, they found that there have been rainfall intensified during monsoon season, and also the extremes is happening. The spread of the rainfall is not that much, which is again giving a start to the monsoonal drought, and the monsoonal drought is also increasing. And now debating your knowledge and debating your work for the summer, in case of the summer drought, there have been some stations for which they have no summer drought events. And also the how the summer drought tends shows earlier onset. Also the winter drought also shows for more than half of there are earlier onset. So how this earlier onset is also accompanying with the increase in the deficit volume. So we'll see in the next slide. Annual seasonal trends in deficit volume. In this case, you can see in the summer the deficit volume is increasing, which is a rate and a negative for, like, which is a worry situations for us. And also in case of winter, also the trend is like the deficit volume is increasing. But when we consider the monsoon, the deficit volume is decreasing, and also for all season it is decreasing. So it is contradicting to the onset. If the onset time is delaying, then the deficit volume will decrease. If the onset time is being earlier, if the onset timing is happening more early, then the deficit volume is going to increase. So now we'll go for spatial clustering of droughts. So in this case, we have been analyzed the spatial clusters, how these trends of the drought deficit volume and the on-site linkage, the coherency between them have been spread out in our study region. For analyzing this, we have used the density-based clustering method, where the concurrence between onset and deficit volume considered as a variable while clustering. Not only that, base flow index, mean rainfall, mean onset time, and mean severity are the other variables which we taken into consider for doing the clustering. So what we found like three clusters. The cluster one is in the north part of the study area, and this northeast part, like this in the middle east part, we got the cluster 2, and the cluster 3 is more over in the south of the peninsular area. And these are the some of the basins which have been air points and not fall in any of the cluster. So now understanding what are the physical controls. there are physical controls like dynamic controls and also static controls. So first we will look into the dynamic controls, rainfall and the soil moisture. So how the rainfall is changing and how the soil moisture is changing in those different three regions. So what we found, in average rainfall is more in the region 1, and the mean rainfall values also is very much in case of the region 1, but in region 2 and region 3, when we go and the average rainfall values declines. Not only that, when we see here in the deficit volume, how the deficit volume and the soil moisture have been for those three regions. So what we found, the region 3 the soil moisture is very more, and also for the region 1 and region 2, if you look, this soil moisture value have been in similar range. But then we have described how the deficit volume is there. So the deficit volume for a particular time period from 1980 to 2018, for where there are a lot of stations having this period of data set. So we have choose this time period, and here what we can say, that when the soil moisture values go up, that and the deficit volumes is drying. So soil moisture somehow supports the supports the declining of the deficit volume. So in this case, when there is soil moisture value is high, we are saying there is very less number of deficit volume. So not only that, but here the deficit volume, there is number of station in region 1 is very much, it is around 50 stations, but region 2 it is only 10 stations, and region 3 it is 13 stations. Not only that, this is a standard deviation of the deficit volume, which also particular showing, and this mean deficit volume on onset, what was the onset date, and how the drought events are spreaded. And you can see the drought events are increasing a lot, and also the deficit volume is going increasing if we observe from the time period also. Not only that, the BFI value also play a important role. So the base flow index, how sometimes help us to sustain the drought events. So when the base flow index will be, but what we found, when base flow index is high, then then the regularity is more often lower. But when the regular BFI index is very low, then the regularity of the onset of the drought is very constant and very high. So when we the catchment properties, these are the catchment properties, like BFI is a catchment properties, and also it shows how it can sustainable throughout the time period. And now we'll go for the static control, understanding the soil and terrain features. So what are the static controls we have been considered? We have considered some of the soil properties and also some of the catchment properties. So these are the soil properties which basically show negative correlations with the drought deficit volume, and also there are a lot of catchment properties which are showing positive correlations value with the drought deficit volume. Not only this, for explaining it more to the audience, we have been draw a tailored skills code diagrams. Not only this will show standard deviations and the RMs, root mean square deviations, also the correlations values. So here what we found, like the correlations values which is higher for this stock at 30 centimeter, and also for stock at 100 centimeter, and also the stock at 30 centimeter and 100 centimeters are showing for the region 3 it is significant. No, if we'll describe more about this is giving a important understanding about these three different reasons. These properties, bearing catchment properties and bearing soil terrain properties, are helping for the memory of the catchment. These are my references I have been used for this presentation. And thank you so much for listening to this topic. Please contact me if you have any queries further. Thank you so much.